Hello students, welcome to the maths class. Today in this video I am going to explain the remaining part of exercise 2C. In this remaining part you are going to study composition of a function and its inverse. Means when two functions will be given, then by using composition how can you show the given two functions are the inverses of each other. One more time I'm telling to you, when two functions are given in the questions, then by using composition how can you show the given two functions are the inverses of each other. That thing I will explain through some questions. Second thing, self inverse functions. Self inverse function means a function is given and that is the inverse of itself. That given function is the inverse of itself. That how can we show? How can we show a given function is the inverse of itself? So that method I will explain through questions. So now you see the questions. You can see here question number 10. Let a equals r minus 2, r minus 2, b equals r minus 1. If function is from a to b defined by fx equals x minus 1 upon x minus 2, then show that f is 1 1 and on to, hence find f inverse. This is not the question based on composition of function. This is the question which you have studied in last video. Yesterday in last video you have studied such type of question. So in this question you have to show first function is invertible. You have to show first function is invertible. Invertible means function is 1 1 on 2, and then you have to find inverse. In my yesterday's video function was given invertible. Already in the question function was invertible, only you were finding inverse. In this question first you will show function is invertible, then you have to find inverse. So this is the difference. So now you see the solution. F such that a to b fx equals x minus 1 upon x minus 2, where a is r minus 2, b is r minus 1, it is given. Now for 1 1 same method you will apply. X1 and x2 belongs to the domain r minus 2 such that fx1 equals fx2. X1 and x2 be the two arbitrary elements belong to the domain r minus 2 such that fx1 equals fx2. fx1 means x1 minus 1 upon x1 minus 2. fx2 means x2 minus 1 upon x2 minus 2. Do cross multiplication. You will get xx1 minus 2x1 minus x2 plus 2 is equal to xx1 minus x1 minus 2x2 plus 2. 2 is cancelled with 2. x1 x2 cancelled with x1 x2. You are having 2x2 minus x2 is equal to 2x1 minus x1. After simplifying you are getting x2 equals x1. So therefore fx1 is equal to fx2 implies that x1 equals x2. So this is the method to show a given function is 1 1 function. So that's why f is 1 1 function. I have written here f is 1 1. fx1 is equal to fx2 implies that x1 equals to x2. So f is 1 1. Next onto, for onto you know, let y equals fx. Y equals fx means y equals x minus 1 upon x minus 2. Do cross multiplication. xy minus 2y equals x minus 1. xy minus x equals 2y minus 1. Take the terms having x on one side and without having x on other side. X is common in LHS, y minus 1 inside the bracket. In RHS 2y minus 1. So x equals 2y minus 1 upon y minus 1, which shows that for every y belongs to the range r minus 1 belongs to the codomain r minus 1, there exists x belongs to the domain r minus 2. One more time I am telling to you, which shows that for every y which belongs to the codomain r minus 1, there exists x which belongs to the domain r minus 2. So it means that range equals codomain. When range equals codomain, f is on 2. So it means that f is 1 1 on 2, and when it is 1 1 on 2, that's why I have written in bracket invertible, because when function is 1 1 on 2, so it will be invertible function. Now when it is invertible, now easily you can find its inverse. So now x equals 2y minus 1 upon y minus 1 you have calculated. Replace x by f inverse y. So f inverse y equals 2y minus 1 upon y minus 1. Now you can take f inverse x. In place of y you put both the sides x. So f inverse x equals 2x minus 1 upon x minus 1, which is the required inverse. So in this way we have shown function is invertible and we have found the inverse. Question number 13. Now composition. Use of composition is coming. By using composition, we will show the given two functions are invertible functions or they are the inverses of each other. So first of all, in the question it is given f such that r to r one function fx equals tan x plus 7. This is given. Find the function g that is also from r to r such that gof equals fog equals ir. This is the condition. Students, you have to keep in mind, if two functions are the inverses of each other, then their composition gof and fog both will equal to identity function. Both will equal to identity function. So this time in the question, one function is given, second function you have to find, and this condition, this composition is given, fog equals gof equals ir. So what is the meaning of this composition? Meaning of this composition is f and g are inverses of each other. So that's why in the solution I am showing to you gof equals fog equals ir. So f and g are the inverses of each other. So when f and g are the inverses of each other, then you can take g equals f inverse. G equals f inverse, because you have to find function g. So if you find f inverse, so that will be function g. One more time I am telling to you, because you have to find g, function g. So if you find f inverse, function f is given, its inverse you find, so that will be function g. So let y equals fx. You can see y equals fx. So y equals tan x plus 7. So y minus 7 equals tan x. When y minus 7 equals tan x, then x equals y minus 7 upon 10. Replace x by f inverse y. So f inverse y equals y minus 7 upon 10. Now both the sides in place of y you can put x. So f inverse x equals x minus 7 upon 10. So this is f inverse x, inverse of function f. So this inverse will be function g. So hence g such that r to r gx equals x minus 7 upon 10. So like this you can find. One more question I am taking. 14 questions. Show that the inverse function of function f whose rule is fx equals 2x plus 1 upon 3x minus 2, x is not equal to 2 upon 3, is f itself. Now you have to show the function inverse of this given function is function itself. The inverse of this given function is this function itself. X is not 2 upon 3 means if x is equal to 2 upon 3, then denominator will be 0 and function will be not defined. So that's why they are saying x is not equal to 2 upon 3. So this is the meaning of the given condition. So how can we show the given function is the inverse of itself? So this is the second point. In the starting of the video I told you self inverse functions. So this function is self inverse function. How can we show? So for this one method is there. You find fx is given, you find f of x. F of x means f of fx, f of fx. So value of fx you put, so f of 2x plus 1 upon 3x minus 2. Now what is the meaning of this f of 2x plus 1 upon 3x minus 2? In the function fx, in place of x you have to put 2x plus 1 upon 3x minus 2. So I have put here, you can see 2 into 2x plus 1 upon 3x minus 2 plus 1, 3 into 2x plus 1 upon 3x minus 2 minus 2. In place of x, full value I have put. Now take LCM. LCM will be cancelled with LCM. In numerator and denominator, separate LCM will be there, and both LCM are equal. So after simplifying, you are getting 4x plus 2 plus 3x minus 2 upon 6x plus 3 minus 6x plus 4. 2 is cancelled with 2 in numerator, 6x is cancelled with 6x in denominator, 7x upon 7 will come. So finally x is coming. So f of x equals x, if this condition is satisfied, you will find whatever function is given. Suppose f is given, so f of x you will find. If it is equal to x, identity function ix, I have written here f of x equals ix. This is the condition I told you in the previous question also, that composition you will use. Composition, if composition comes equal to identity function, then function is the inverse of each other. In the previous question, two functions were there, here one function is there. So composition of the given function with itself, it is coming identity function. So with itself it is the composition. So that's why this is the function self inverse function. So f is invertible and inverse of f is itself. So that's why I have written f is invertible and inverse of f is itself. So this is self inverse function. Next question, last question. Use composition to show that f and g are inverses of each other. Here two functions are given, fx equals 1 upon x plus 1, gx equals x 1 minus x upon x. Fx 1 upon x plus 1, gx 1 minus x upon x. So solution you can see. So fog you find and gof you find. Fog x, f of gx, gx value you have put 1 minus x upon x. Now in the function fx, in place of x, you have to put 1 minus x upon x. So here you can see 1 upon 1 minus x upon x plus 1. Simplify it. So 1 upon 1 minus x plus x upon x. This x will go in numerator. So it will be x upon 1 equals x. So fog x equals coming x, identity function. Now gof you check. Gof x equals g of fx. Fx value 1 upon x plus 1. Now in the function gx, in place of x you have to put 1 upon x plus 1. So I have put here, you can see 1 upon 1 minus 1 upon x plus 1 upon 1 upon x plus 1. 1 minus 1 upon x plus 1 upon 1 upon x plus 1. So here you can see, by simplifying, x plus 1 minus 1 upon x plus 1 in numerator, 1 upon x plus 1 in denominator. X plus 1 is cancelled with x plus 1. 1 is cancelled with 1. X upon 1 x. So fog equals gof equals x. So this is the condition. They are the inverses of each other. So f and g are the inverses of each other. So in this way we have shown how can we show, means inverses, given functions are the inverses of each other. So this was the use of composition to show given functions are inverses of each other. So I have completed this exercise. In the remaining part, remaining questions you solve. If you have any problem in solving the remaining questions, so you can ask, I will clear your doubts. And one more thing I will tell you, today is the last video before summer vacations. Now tomorrow onwards your summer vacations start. So if you have any doubt, then you can ask, no matter, I will clear your doubts in comments. So thank you, have a nice day and happy holidays.